Out beyond Neptune, in the cold, silent reaches of our solar system, lies a place few of us ever think about: the Kuiper Belt, a vast, dark frontier of icy bodies and dwarf planets. It's a graveyard of primordial leftovers from the birth of our cosmic neighborhood. But lately, something strange has been stirring in that frozen void. Signals unexplained, erratic, and utterly baffling have been detected, whispering secrets that defy everything we thought we knew about this distant realm. These aren't the predictable radio bursts of distant stars or the static hum of cosmic background radiation. These signals are different. They pulse, they fade, they reappear where they shouldn't. And no one can fully explain why. Imagine for a moment what it would mean if these signals weren't just random cosmic noise. What if they were deliberate? A message, a beacon, or even, dare we say it, something artificial. The very idea sends shivers down the spine of even the most seasoned astronomers, because the Kuiper Belt isn't just some barren wasteland. It's a place where Pluto, once considered our ninth planet, still dances in the shadows, where spacecraft like New Horizons have glimpsed landscapes more alien than anything we've seen closer to home. And now, hiding in all that darkness, something is communicating. Or at least that's what the data seems to suggest. Tonight, we're diving deep into one of the most unsettling space mysteries of our time. 40 strange signals, each one a puzzle wrapped in an enigma, detected over the past few years from the Kuiper Belt. Some flicker like a dying candle, others repeat in patterns that almost feel intentional. Scientists have scrambled to explain them: frozen gases releasing energy, unseen moons interacting with magnetic fields, or could it be something far more extraordinary? Whatever the answer, these signals are rewriting the rules of what we thought was possible in the outer solar system. So buckle up, because by the time this journey is over, you'll never look at the night sky the same way again. The first signal that truly made scientists sit up and take notice was unlike anything they'd ever picked up from the Kuiper Belt before. A rhythmic, almost mechanical pulse, repeating at intervals so precise they defied the chaos of deep space. Detected by multiple deep space probes over a span of 18 months, this wasn't the erratic crackle of solar wind or the faint whisper of distant comets. It had a beat, a steady, unflinching cadence like a metronome ticking in the void. What made it even stranger was its frequency, a narrow band just outside the typical range of natural cosmic noise, as if whoever, or whatever, was sending it wanted to be heard clearly. Most natural emissions from icy bodies are messy, scattered across the spectrum, but this was a laser-sharp signal, cutting through the background static like a beacon. And then there was its duration. Unlike fleeting bursts from collapsing asteroids or plasma discharges, this pulse held steady for minutes at a time before vanishing, only to reappear weeks later, always in the same general region near the orbit of Haumea, one of the Kuiper Belt's dwarf planets. Astronomers ran through every conventional explanation. Could it be some bizarre interaction between Haumea's icy surface and solar radiation? Unlikely. The signal's timing didn't match the dwarf planet's rotation. Maybe a previously unknown moon, its gravity triggering electrical currents in the surrounding dust, but nothing in our models predicts such a clean, repeating pattern. The more they studied it, the more the data seemed to whisper something unsettling. This wasn't just another quirk of nature, it was a signal that behaved as if it were engineered to be noticed. And then, just as suddenly as it began, the pulse stopped. No gradual fade, no distortion. One day it was there, the next silence. But here's the chilling part: 3 years later, it came back. Same frequency, same rhythm, as if whatever sent it had simply taken a break. That's not how natural cosmic phenomena work. Stars flare and die, asteroids collide, but they don't follow schedules. Unless, of course, they're not natural at all. Theories started flying the moment that strange pulse was detected, each more intriguing, and in some cases more unsettling than the last. On the scientific side, one leading hypothesis pointed to cryovolcanism. Imagine geysers on Earth, but instead of scorching water, they blast frozen nitrogen or methane into space. If Haumea had active cryovolcanoes, something we've seen hints of on other Kuiper Belt objects, the sudden release of pressurized gas could, in theory, create electromagnetic ripples. But here's the catch: cryovolcanic bursts are chaotic, messy. They don't produce signals with the precision of a Swiss watch. Then there's the idea of tidal forces at play. Haumea spins faster than any other known dwarf planet, completing a rotation in just under 4 hours. That dizzying speed, combined with its oblong shape, creates intense gravitational stresses. Some researchers speculated that these forces might be squeezing pockets of electrically conductive slush beneath the surface, generating currents that could emit radio waves. It's a clever explanation, except the math doesn't quite add up. The signal's regularity was too perfect, its frequency too narrow. Natural processes tend to wobble, to drift. This didn't, of course. Not all possibilities stay within the bounds of known physics. Some astronomers quietly raised the specter of artificial origins. Not necessarily aliens, though that's the headline everyone jumps to, but perhaps something even wilder: an ancient probe. The Kuiper Belt is littered with relics from the solar system's formation, frozen time capsules from 4.5 billion years ago. What if, buried in that icy rubble, there's a piece of leftover technology from a civilization that rose and fell before Earth's continents even took shape? Far-fetched, absolutely, but when you've ruled out every natural explanation, even the improbable starts to feel possible. Then there's the darkest interpretation of all: what if the signal wasn't meant for us? Imagine a beacon set millions of years ago, programmed to wake up only when certain conditions were met. Maybe it detected new horizons buzzing through the Kuiper Belt and stirred to life, sending out a handshake into the void. Or maybe, just maybe, it's been transmitting all along and we're only now learning how to listen. Whatever the truth, one thing's certain: that first pulse rewrote the playbook. Because if something in the Kuiper Belt is capable of sending signals this precise, this deliberate, then the outer solar system just became infinitely stranger than we ever dreamed. And as we're about to see, it was only the beginning. Just when scientists thought they'd seen the strangest the Kuiper Belt had to offer, another signal erupted from the darkness, this one so violent, so inexplicably powerful, it lit up detectors like a cosmic flashbang. Unlike the precise, metronomic pulse that came before, this was raw energy unleashed, a sudden burst of radio waves packing more punch than anything naturally occurring that far from the sun should theoretically produce. It lasted less than 2 seconds, but in that blink of cosmic time, it rewrote the rules of what we thought was possible in the outer solar system. The numbers alone were staggering. This burst carried thousands of times more energy than typical emissions from Kuiper Belt objects, equivalent to a lightning bolt fired from the surface of Pluto. But here's what really twisted the mystery deeper: the signal's fingerprint didn't match any known astrophysical phenomenon. Not magnetar flares, not pulsar glitches, not even the explosive collisions of icy bodies. Its spectral signature was wrong, too clean, too focused, like someone had taken the messy, broadband roar of a supernova and squeezed it into a laser beam. And then there was the location problem. The burst originated from a patch of sky near Makemake, another dwarf planet, but when telescopes swiveled to look, there was nothing there. No comet, no asteroid breakup, no rogue chunk of debris, just empty space whispering with background radiation. That absence was louder than any explosion. Because in astronomy, energy always leaves footprints, heat signatures, debris clouds, something. This burst left nothing but questions. Theories ricocheted through the scientific community. Could it have been a mega cryovolcano, a hypothetical, ultra-powerful eruption of subsurface liquids? Possibly, but no known geological process, even on Earth, releases energy that fast. Others suggested a primordial black hole, smaller than an atom but weighing as much as a mountain, evaporating in a final burst of Hawking radiation. Fascinating, but statistically, such an event happening right where we were listening would be like winning the cosmic lottery 10 times in a row. Then came the real curveball. When researchers dug through old data, they found two nearly identical bursts, one from 1994, another from 2007, both from the same general region. Same frequency profile, same eerie lack of afterglow. 3 bursts across 30 years, each a perfect copy of the others. Natural events don't repeat like that. Not with such surgical precision, unless of course they're not natural at all, which leaves us with the unsettling truth. Something in the Kuiper Belt is capable of unleashing titanic energy on demand. Something that hides its tracks perfectly, and something that, judging by the pattern, isn't done yet. When astronomers first grappled with that mysterious burst of energy from the Kuiper Belt, one of the most straightforward explanations seemed to be collisions. After all, the region is littered with icy bodies, some the size of mountains, others as large as continents, all drifting in orbits that occasionally cross paths. A high-speed impact between two of these objects would certainly release a tremendous amount of energy. But as researchers dug deeper, the math started to unravel in ways no one expected. First, consider the sheer force required. For a collision to produce a radio burst that intense, the objects involved would need to be massive. Think 2 Pluto-sized bodies slamming together at orbital speeds. Yet nothing on that scale has been observed in the Kuiper Belt for millennia. Current models suggest catastrophic collisions of that magnitude should happen only once every few 100 million years. And even then, they'd leave behind debris clouds visible for centuries. But when telescopes scanned the area, they found no trace of fresh wreckage, no expanding rings of dust. Just empty space where the burst had been. Then there's the timing problem. Natural impacts are chaotic, unpredictable. They don't occur in near-identical bursts decades apart. If this were debris from some ancient collision, why would it flare up so precisely in 1994, then again in 2007, and once more just recently? Impacts don't schedule themselves like clockwork, unless, of course, what we're seeing isn't debris at all, but something far more controlled. Some scientists proposed a more exotic twist. What if the collision wasn't between natural objects? The Kuiper Belt could be home to relics of incredible density fragments of neutron stars, or even stranger, hypothetical objects like quark nuggets. A collision involving one of these ultra-dense bodies might explain the energy release without leaving obvious debris. But again, the repeat performance throws a wrench in the theory. Natural collisions are one-time events. They don't rewind and replay. Which brings us to the most unsettling possibility of all. What if the burst wasn't a collision at all, but the result of something tapping into stored energy? Imagine an ancient structure or even a natural phenomenon we've never encountered capable of discharging power in controlled bursts. It sounds like science fiction, but remember, the universe is under no obligation to operate within the limits of our imagination. Every time we've assumed we've seen all nature has to offer, the cosmos has laughed and proved us wrong. So where does that leave us? The collisional theory isn't entirely ruled out, but it's hanging by a thread. And when the simplest explanations crumble, that's when things get truly interesting. Because out in the frozen dark, something is sending signals we can't explain. And it's not done yet. Of all the signals drifting in from the Kuiper Belt's frozen expanse, none sent chills through the astronomy community quite like the one they called the whispering echo. Unlike the violent burst or the mechanical pulse, this one didn't announce itself with fanfare. It slithered into detection, a faint, ghostly repetition of transmissions we'd sent from Earth decades earlier. Not copies exactly, more like distorted reflections, as if someone or something had heard our messages and was whispering them back to us, warped by time and distance. The timeline alone is enough to unsettle. In 1972, NASA Pioneer 10 probe blasted a radio greeting toward the stars, a simple pulse of data containing humanity's location, a diagram of our solar system, even a crude image of a man and woman. Routine stuff barely noticed after it vanished into the void, until 2019, when a radio telescope in Chile picked up a signal from the general direction of the Kuiper Belt. Same frequency band, same basic modulation, but twisted. Elements of the original message were there, just fractured, rearranged, like a broken mirror reflecting pieces of the past. Here's what makes it impossible to dismiss as coincidence. The echo wasn't a one-time event. Over the next 4 years, 6 more followed, each replaying fragments of different Earth transmissions, from Cold War-era military radar pings to snippets of early satellite telemetry. Always degraded, always shifted slightly in frequency, but undeniably derived from our own broadcasts. The spacing between echoes wasn't random either. They arrived at intervals matching the light travel time to specific Kuiper Belt objects, as if bouncing off surfaces we'd yet to discover. Explanations. Few make sense. Natural radio echoes require massive, smooth reflectors. Think moon-sized sheets of ice or metal floating in space. But scans show nothing of the sort out there. Solar wind can't account for the precision, and interstellar plasma would scramble the signals beyond recognition. That leaves 2 possibilities equally unnerving. Either we're seeing an entirely new astrophysical phenomenon, some kind of cosmic mirror nature forgot to tell us about, or something in the Kuiper Belt is listening. And if it's listening, what happens when we send a message meant to be heard? The whispering echo forces us to confront a question that straddles the line between science and speculation. Is this nature's strange coincidence or something far more deliberate? On one side of the debate, astronomers point to precedents in our own solar system, like the way Jupiter's ionosphere sometimes bounces radio signals back to Earth, distorted but recognizable. Could some unknown feature in the Kuiper Belt, a vast hyper-reflective ice sheet or an oddly shaped dwarf planet, be acting as a cosmic mirror? It's not impossible. After all, Pluto's heart-shaped glacier, discovered by New Horizons, proved that even distant worlds hold geological surprises, yet the skeptics counter with cold, hard physics. For a natural object to reflect signals with such clarity across billions of miles, it would need to be impossibly smooth and impossibly large. Think a frozen plain wider than Texas, angled precisely toward Earth. Even then, echoes degrade over distance, their fingerprints smudged by interstellar plasma. The whispering echo, though warped, retained structure, like a song played backward but still recognizable. Nature doesn't curate, it doesn't cherry-pick decades-old transmissions and send them home with eerie timing. This is where science fiction's ghost stories start feeling uncomfortably relevant. The echo mirrors plots from classics like Arthur C. Clarke's The Sentinel, where ancient lunar artifacts wait to broadcast humanity's first radio pulses back as a cosmic alarm bell. Or Stanislaw Lem's His Master's Voice, where scientists decode an indecipherable signal only to realize it might be a mirror reflecting their own assumptions. Fiction has long warned us, if the universe ever speaks back in our own voice, we should be very, very careful how we answer. Then there's the darker interpretation, one that whispers of surveillance. Military radar, early satellite pings, pioneers' greeting. These weren't random broadcasts, they were humanity's first energetic footsteps into the cosmos. If something is listening, those signals would be the equivalent of a doorbell ringing in the void. The chilling precision of the intervals, each echo arriving just as Earth's original transmission, would have reached a specific Kuiper Belt object, hints at a mind-bending possibility. Whatever's out there might be mapping us, using our own signals as sonar to pinpoint our location. But perhaps the most unsettling thought isn't about malice or even intelligence. What if the echo is simply physics we don't yet understand? A phenomenon where space-time itself kinks around massive objects, creating natural recording effects. Or some quantum fluke where entangled particles preserve information across light years. The universe is under no obligation to fit our textbooks. Every unexplained signal is a reminder we've barely scratched the surface of what's possible. One thing's certain: the whispering echo refuses to be ignored. Because whether it's ice or intention out there in the dark, something is reminding us that space isn't silent. It's listening, and if we're smart, we'll listen back. Amidst the eerie silence of the Kuiper Belt, something began harmonizing. Not random noise, not chaotic bursts, but precise, interwoven frequencies. 8 distinct signals pulsing in perfect mathematical ratios, like notes in a chord struck across the cosmos. Dubbed the Harmonic cluster, this phenomenon wasn't just strange, it was statistically absurd. The odds of natural emissions aligning in such ratios by chance. Astronomers calculate them at roughly 1 in several billion. Yet there they were, resonating from the void as if tuned by some unseen hand. What made this cluster defy explanation wasn't just its musicality. Each signal occupied a narrow frequency band, clean and steady, untouched by the Doppler shifts you'd expect from orbiting bodies. They held their pitch unwavering, even as their sources moved through the gravitational dance of the Kuiper Belt. More perplexing still, their spacing followed the harmonic series, the same mathematical relationships found in vibrating strings, wind instruments, even quantum energy levels. Nature produces noise, not melodies, unless, of course, it's not nature at all. Scientists scrambled for analogies. Could tidal forces on icy moons create resonant vibrations? Possible, but no known world in our solar system sings in such pure tones. Others suggested magnetospheric interactions, where charged particles spiral around magnetic fields, generating radio waves. Yet even Jupiter's furious auroras, the loudest natural radio source in our neighborhood, sound like static compared to this celestial symphony. The cluster's precision pointed to something far more unsettling: coherence. A quality rarely seen outside engineered systems. Then came the kicker. When researchers analyzed the timing, they found the signals weren't just harmonically aligned, they were conversing. Each pulse adjusted minutely in response to the others, as if locked in a feedback loop. This wasn't a choir singing in unison. It was a call and response, a pattern seen in everything from firefly flashes to human communication networks. The implication: either the Kuiper Belt harbors a natural process mimicking intelligence, or we're detecting something that chooses to harmonize. The universe has whispered many secrets, but never one so hauntingly deliberate. Because if harmony exists in the dark, what else might be listening? The patterns in the harmonic cluster weren't just orderly, they were eerily precise, following mathematical relationships that don't typically emerge from random cosmic processes. Each of the 8 frequencies locked into ratios matching the harmonic series' whole number multiples of a fundamental tone, like a cosmic octave stretched across the radio spectrum. The intervals between them corresponded to perfect fifths, major thirds, and other consonances found in music across human cultures. Mathematicians ran the numbers and found something even stranger. The frequencies aligned with prime number ratios, a pattern so statistically rare in natural emissions that one researcher likened it to finding a snowflake shaped like a Fibonacci spiral. This wasn't just harmony, it was encoded harmony. The signals maintained their ratios even as their sources moved relative to Earth, defying the Doppler shifts that should have warped their pitches. Imagine a piano playing a chord, and no matter how fast you spin the piano, the notes stay perfectly in tune. That level of stability doesn't happen in nature without some form of correction, a mechanism actively resisting entropy. The only known processes that achieve such precision are human-made, like atomic clocks or synchronized communication networks. Astrobiologists chimed in with a provocative thought: harmonic ratios are universal. The same math that structures a Bach fugue also governs molecular vibrations and planetary orbits. If an intelligence wanted to broadcast its presence across the cosmos, harmonics would be an ideal language, a bridge between physics and meaning. But here's the rub: no known natural phenomenon in the Kuiper Belt should produce such ratios. Ice vibrations, plasma oscillations, even magnetospheric resonances all trend toward noise, not music. Unless, of course, we're missing something fundamental about how matter behaves in the outer solar system's extreme cold. Then there's the timing. The cluster's signals didn't just harmonize, they evolved. Over 17 months, the intervals between pulses shortened by a factor of pi, as if counting down. When mathematicians modeled the pattern, they found it mirrored a logarithmic spiral, a shape seen in galaxies, hurricanes, and even the cochlea of the human ear. Coincidence possible, but when you combine geometry, harmonics, and precise timing, the argument for random noise starts feeling flimsy, which leaves us with two possibilities, both staggering. Either we've stumbled upon a previously unknown natural phenomenon, one that mirrors the structured beauty of human mathematics, or the Kuiper Belt is hiding something that understands the language of ratios. And if it's the latter, the next question is inevitable: who's listening? Then came the signal that didn't just whisper or sing, it shouted with the persistence of a lighthouse cutting through fog, only to vanish as if it had never been there at all. Detected simultaneously by radio telescopes in Arecibo and Green Bank, this emission pulsed on a precise 23-minute cycle for 37 days straight, long enough for astronomers to pinpoint its origin near Quaoar, a mid-sized Kuiper Belt object. What set it apart wasn't just its regularity, but its stability. The signal's intensity never wavered by more than 1%, an absurd level of consistency for anything natural in the chaos of deep space. At first, researchers assumed it was a neutron star's work. Pulsars, after all, are cosmic metronomes, spinning with such regularity that their radio beams sweep past Earth like clockwork. But the numbers refuse to cooperate. A pulsar's spin slows over time as it loses energy, its rhythm decaying by microseconds each year. This signal, it didn't drift, not even by a nanosecond. It was as if whatever produced it had access to an atomic clock immune to the universe's entropy. Even stranger, its frequency was suspiciously close to the hydrogen line, the universal radio benchmark astronomers used to search for extraterrestrial intelligence. A cosmic coincidence, maybe, but the universe rarely winks without reason. Then there was the signal's abrupt departure. Unlike natural transients, say, a magnetar's flare or a dying comet's final burst, the beacon didn't sputter or fade. It simply stopped. One moment it pulsed with the reliability of a heartbeat, the next silence. Telescopes scrambled to check for equipment failures, solar interference, anything, but the void offered no answers. The most thorough sky surveys found nothing where the signal had been. No new objects, no debris fields, no afterglow. Just empty space where a cosmic presence had announced itself for weeks, then stepped behind the curtain. Theories spiraled. Could it have been a maser, a naturally occurring microwave laser powered by Quaoar's subsurface ocean? Europa and Enceladus have water plumes that generate weak maser emissions, but nothing this powerful or precise. Others proposed a rogue pulsar, a hypothetical neutron star drifting through the Kuiper Belt. Yet pulsars are born in supernova, and no stellar explosion has rocked our solar system in millions of years. Besides, pulsars don't just turn off, they slow, they glitch, they die in crescendos of X-rays. They don't vanish mid-pulse like a switched-off bulb. Then came the fringe explanations whispered in conference hallways. A probe, a relic, something artificial that had finished its transmission and powered down. The unnerving truth is this: In all of astronomy, we have no natural analog for a signal that behaves with such precision and then winks out without a trace. Most cosmic events leave forensic evidence, heat, light, debris. This left nothing but questions, and the most chilling question of all, if it was a beacon. What was it signaling, and to whom? The moment the beacon vanished, astronomers didn't just shrug and move on. They launched the most meticulous search in deep space radio astronomy history. Dozens of telescopes, from the mammoth dishes of the Very Large Array to the ultra-sensitive antennas of the Allen Telescope Array, pivoted toward Quasar's patch of sky, scanning for even a whisper of the signal's return. Scientists programmed algorithms to sift through petabytes of static, hunting for that distinctive 23-minute pulse. Months turned into years. Nothing. The silence was so absolute, so unnatural, it became its own kind of message. But here's what makes the search fascinating. Even absence tells a story. Those years of radio silence ruled out entire categories of explanations. If this had been some exotic natural process, a quake in Quasar's ice crust, say, or a chain reaction in subsurface chemicals, it should have repeated by now. Transient cosmic events follow patterns. Magnetars flare, comets fracture, neutron stars glitch. They don't perform once and exit stage left, unless, of course, they're not natural at all. Theories about the beacon's disappearance grew increasingly bold. One camp suggested it might have been a self-terminating phenomenon, like a cosmic egg hypothesis, where an ancient structure, buried in ice for eons, briefly activated upon exposure to sunlight or cosmic rays before exhausting its energy. Others proposed it was a targeted transmission, intentionally brief to avoid detection by anything or anyone else. The eeriest possibility that we missed its return. Signals from the Kuiper Belt take hours to reach Earth. If the beacon pulsed while our telescopes were turned elsewhere, or if its frequency shifted slightly outside our detection range, it could be repeating right now unseen. Then there's the unsettling corollary to its disappearance: timing. The beacon vanished just as New Horizons, the same probe that gave us our first close-up of Pluto, was scheduled to adjust its trajectory toward a Kuiper Belt object called Arrokoth. Pure coincidence, maybe, but in a solar system suddenly bristling with strange signals, even coincidences start feeling like punctuation marks in a sentence we can't quite read. So where does that leave us? The hunt continues, now augmented by next-gen observatories like the Square Kilometre Array, capable of detecting whispers 1,000 times fainter than before. Astronomers have even begun monitoring Quasar's vicinity in other spectra: infrared, X-ray, even gravitational waves, in case the beacon wasn't speaking in radio at all, but in some language we've yet to recognize. Because the deepest truth the silence taught us isn't that the signal's gone. It's that the universe is vast enough to hide even its loudest mysteries in plain sight. And we're only beginning to learn how to look. In the cold expanse of the Kuiper Belt, where most signals dissolve into static, one transmission stood out not for its power or persistence, but for its unsettling resemblance to a language we invented. Designated Signal 6, it arrived in bursts of two distinct tones, a high-frequency pulse and a low-frequency hum, alternating in sequences that lasted exactly 8 seconds each. At first glance, it could have been dismissed as random noise, but when researchers fed the data into a spectrogram, a pattern emerged, one that mirrored the binary code humans have used for centuries to encode information. Zeros and ones translated into sound, the resemblance was uncanny. The signal's short bursts formed repeating blocks of 8 bits, just like the bytes that make up digital data. Even more striking, certain sequences matched binary representations of prime numbers, a hallmark of intentional signaling famously proposed by astronomers Carl Sagan and Frank Drake as a potential universal language. The odds of this happening by chance, astronomers calculated them at less than 1 in 10 million. Yet there it was, a signal from beyond Neptune that seemed to speak in the same stripped-down logic as our computers. Skeptics argued it had to be pareidolia, the human brain's tendency to find patterns in randomness, like seeing faces in clouds. After all, nature produces binary-like signals all the time. The tick-tock of pulsars, the on-off flicker of magnetic reconnection events. But Signal 6 didn't just resemble code, it followed rules. The 8-bit structure held rigid across hundreds of transmissions. The prime number sequences reappeared at intervals that defied random distribution. And then there was the kicker, when researchers converted the binary into ASCII, the standard system for encoding text. A handful of sequences translated to symbols specifically, the mathematical constants pi and Euler's number. Could ice or rock spontaneously generate such patterns? Unlikely. Binary code is a human construct, a way to represent logic gates and voltage states. No known natural process in the Kuiper Belt organizes itself into bite-sized chunks or spits out meaningful mathematical constants. Even if some exotic geological activity, say electrically charged ice fracturing in precise rhythms, could produce binary-like pulses, it wouldn't select for primes or transcendental numbers. Unless, of course, the selection wasn't natural at all. The implications send a shudder through the scientific community. If Signal 6 isn't random, if it carries even the faintest whiff of intentional encoding, then the Kuiper Belt might hold something far stranger than frozen debris. Something that speaks in a language we recognize because, in the grand cosmic coincidence, we invented a similar one. Or worse, something that recognized us first and is now replying in terms we can't ignore. Either way, one truth becomes unavoidable. Out in the dark, something is counting, and it's using our own numbers to do it. The moment Signal 6's binary-like structure was confirmed, cryptographers and astronomers formed an unlikely alliance. One group fluent in the language of ciphers, the other in the dialects of deep space. Their first task: rule out human interference. Could this be some glitch from an old satellite, or a reflected transmission from Earth's own digital noise? The answer came swiftly. Signal 6's origin point was fixed deep in the Kuiper Belt, far beyond any human-made object. Its 8-second cadence matched no known terrestrial technology. This wasn't an echo of our own chatter, it was something new. Researchers then turned to the sequences themselves. Using prime numbers as a Rosetta Stone, teams at the SETI Institute and Breakthrough Listen project began parsing the pulses for mathematical meaning. Early attempts focused on universal constants, ratios like the fine structure constant or the hydrogen line frequency, hoping to find a cosmic handshake. But the signal refused to conform. While fragments aligned with pi and Euler's number, other sections defied interpretation, flickering between coherence and chaos like a half-finished equation. Controversy erupted when a team from the University of Tokyo claimed to find geometric patterns in the code. Converting the binary into three-dimensional coordinates, they generated a shape resembling a truncated octahedron, a structure found in everything from crystal formations to viral capsids. Skeptics countered that any random data set can be forced into patterns if you tweak the parameters enough. The debate grew heated, with accusations of cosmic pareidolia flung across academic journals. Then came the wildcard theory from a former NASA systems engineer. What if the signal wasn't a message at all, but a beacon's handshake protocol? In computer networks, devices exchange standardized signals to establish communication: brief, repetitive bursts that say, in essence, "I'm here." Signal 6's rigid structure and prime number scaffolding fit that model eerily well. If true, it would imply something in the Kuiper Belt isn't just broadcasting, it's waiting for a response. Yet the most unsettling analysis came from an unexpected corner: linguistics. A group at the University of Edinburgh applied techniques used to decode ancient scripts, treating the signal as an unknown language rather than pure mathematics. Their algorithms detected something startling: statistical properties resembling Zipf's law, a pattern seen in all human languages where the most frequent words appear predictably often. Natural noise doesn't follow Zipfian distributions, language does. The implications are as profound as they are unsettling. If signal 6 carries even the faintest shadow of linguistic structure, then the Kuiper Belt may hold something that doesn't just compute, it communicates. And if that's true, the next question isn't just what the signal says, but what we should say back. Of all the enigmas drifting from the Kuiper Belt, none blurred the line between physics and fantasy quite like Signal 7, a transmission wrapped in a thermal riddle. Unlike the harmonic clusters or binary-like pulses, this anomaly didn't just whisper in radio waves, it radiated heat. Infrared telescopes picked it up first. A patch of space near the dwarf planet Orcus glowing 5 degrees warmer than its surroundings, pulsing in sync with a faint but unmistakable radio signal. For a region where temperatures hover near absolute zero, that subtle warmth might as well have been a bonfire, and the cause, nothing we've ever seen in the outer solar system. The numbers defied conventional models. The heat signature spanned an area roughly the size of Alaska, yet scans revealed no massive object to explain it, no hidden moon, no comet swarm, no rogue planetesimal. Just empty space, inexplicably retaining warmth as if something beneath the ice or beyond our sight was bleeding energy into the void. Even stranger, the thermal pulses followed a 17-hour cycle exactly matching Orcus's rotation. That kind of synchronization doesn't happen by accident. If this were geothermal activity like the cryovolcanoes on Europa, the heat should lag or vary as subsurface slush shifted. Instead, it kept perfect time like a clock whose gears were welded to the dwarf planet's spin. Theories flared like sparks in a vacuum. Could tidal forces from Orcus's moon, Vanth, be generating friction deep beneath the ice? Possibly, but calculations showed the effect would be 1,000 times too weak. Others proposed a dark, icy mantle trapping residual heat from radioactive decay, except the Kuiper Belt's primordial rocks lacked the heavy isotopes needed for such sustained warmth. Then came the wild card. What if the heat wasn't natural at all? The signal's radio component pulsed at a frequency used by NASA deep space probes for thermal regulation. A coincidence, surely, unless something out there had repurposed the same physics deliberately. The most unsettling clue lay in the data's fine print. Spectrographic analysis revealed trace emissions of nitrogen gas, a compound common in Pluto's atmosphere but unheard of in Orcus's frozen wastes. Unless, of course, something had vaporized a pocket of subsurface nitrogen ice or vented it intentionally. When researchers cross-referenced old surveys, they found the same thermal spike had occurred twice before in 1998 and 2009, always lasting exactly 42 days before vanishing. Natural processes don't punch time cards. Which leaves us staring into the dark with one unshakable question. If the Kuiper Belt is hiding a heat source, what's powering it? A subterranean ocean. A pocket of exotic matter, or something that, against all odds, knows how to turn the cold into a signal we can't ignore. If something in the Kuiper Belt is pulsing with heat but remains invisible to our telescopes, what exactly are we not seeing? The most tantalizing possibility is that Signal 7 isn't coming from empty space at all, but from objects lurking just beyond the edge of detection. Rogue planets, for instance, these nomads of the cosmos unbound to any star, drift through interstellar space, often colder than the background void. But what if one, kicked inward by some ancient gravitational shuffle, now hides in the Kuiper Belt's shadowy fringes? A planet even a fraction of Earth's mass could retain enough internal heat from radioactive decay or tidal friction to emit the faint warmth we're detecting. The hitch: current surveys should have spotted something that large, unless of course it's darker than we expect. A world cloaked in ultra-black organic ices, or one sheathed in a kilometer-thick crust of light-absorbing carbon, could evade our optical scans while still leaking heat into space. Then there's the wilder card: primordial black holes, hypothetical remnants from the Big Bang. These could be as small as an atom yet weigh as much as a mountain. If one drifted through the Kuiper Belt, its Hawking radiation, the faint glow predicted by quantum physics, might explain the heat anomaly. The math is shaky but not impossible. Such an object would warp space-time subtly, bending light around it like a cosmic mirage. Recent reanalysis of New Horizons trajectory data found unexplained microshifts in the probe's speed as it passed Orcus's orbit, exactly the kind of perturbation a dense, invisible mass might cause. But let's stretch the imagination further. What if the heat signature isn't natural at all? The radio pulses synchronized to Orcus's rotation suggest precision, a hallmark of engineering. Imagine a megastructure buried in ice for eons, now intermittently powering up. On Earth, we've theorized about Dyson spheres harnessing star energy. In the Kuiper Belt's cold, perhaps the goal isn't energy collection but heat conservation. A dormant probe or relay station, designed to activate only when conditions align, like a spacecraft passing nearby, could emit controlled bursts of waste heat as it cycles systems. It's speculative, yes, but remember, the universe is 4.5 billion years older than our civilization. Plenty of time for others to have come and gone, leaving artifacts in the freezer of deep space. The most haunting clue lies in the nitrogen emissions. Nitrogen is a stellar refrigerant, used in everything from spacecraft cooling systems to preserving biological samples. Its presence around Orcus suggests something is either actively managing temperature or was designed to do so before failing. Either way, the Kuiper Belt keeps whispering one uncomfortable truth: we're not just missing pieces of the puzzle. We might be missing entire pages of the manual. Of all the signals pouring in from the Kuiper Belt, none defied the laws of motion quite like Signal 8. At first glance, it seemed ordinary, a steady radio hum emanating from the vicinity of the dwarf planet Gong. But when astronomers analyzed its frequency, the numbers made no sense. The signal wasn't just Doppler shifted, as expected from a moving object. It was hyper-shifted, warping and snapping back as if its source were accelerating and decelerating at impossible speeds. Like a car revving from 0 to 60 and back to 0 in a heartbeat, over and over without inertia. The physics behind this is where things get truly bizarre. In our solar system, every object follows predictable orbital mechanics. A moon orbits a planet, a comet swings past the sun, all governed by gravity's unbreakable rules. Doppler shifts from these objects change smoothly as they move toward or away from us, but Signal 8's frequency didn't curve. It jittered, zigzagging across the spectrum in sharp, unnatural spikes. At one point, the shift suggested the source accelerated to nearly 200 kilometers per second, then reversed direction just as fast. That's not just improbable, it violates conservation of momentum. Even a spacecraft with infinite fuel couldn't pull off such maneuvers without tearing itself apart. Then came the real head-scratcher: the pattern wasn't random. Detailed analysis revealed the shifts followed a fractal sequence, a mathematical rhythm where each acceleration event mirrored smaller versions of itself, like a coastline viewed from space. Fractals appear everywhere in nature, from snowflakes to galaxy clusters, but they don't govern motion. You don't see comets tracing Mandelbrot curves. Unless, of course, something is imposing that pattern artificially. Skeptics scrambled for conventional explanations. Could it be plasma turbulence in Gong's faint atmosphere? Unlikely. The required energy would vaporize the dwarf planet. A swarm of micro-comets colliding in sequence, the odds of such perfect timing are astronomically slim. The only natural phenomenon that comes close is pulsar glitching, where neutron stars suddenly speed up their spins. But pulsars don't exist in the Kuiper Belt, and their frequency changes are messy, not surgically precise. This left researchers staring at two equally unsettling possibilities. Either we've discovered a fundamentally new astrophysical process, one that bends the rules of motion as we know them, or something out there is playing with physics. Imagine a probe equipped with technology we can't yet fathom, maneuvering in ways that mock Newton's laws. Or consider an even darker thought. What if the signal isn't coming from a physical object at all, but from something warping space-time itself? Because here's the chilling truth. In all the cosmos, only one thing should be able to accelerate without inertia. A flaw in the fabric of reality, a knot in space-time. And if that's what we're detecting, then the Kuiper Belt isn't just hiding mysteries. It's rewriting physics. When a signal like this appears to break the known rules of physics, scientists face a crossroads. Do we rewrite the textbooks, or is there a simpler explanation hiding in the data? The first instinct is always to assume we're missing something. After all, history is littered with impossible phenomena that turned out to be measurement errors or overlooked variables. Take the infamous Pioneer anomaly, where spacecraft seemed to defy gravity only for researchers to eventually trace it to heat radiating unevenly from their power systems. Could Signal 8's jittering Doppler shifts be similarly mundane? One potential culprit, multipath interference. In Earth's urban canyons, radio signals bounce off buildings, creating ghostly echoes that confuse GPS. Maybe Gong Gong's irregular shape, a lumpy, elongated world, is scattering the signal in ways we don't yet understand. If part of the transmission ricochets off a hidden ice cliff or subsurface metal deposit, it could arrive at Earth slightly delayed, mimicking impossible acceleration. The problem, multipath distortion usually smears frequencies, not creates razor-sharp fractal patterns, and Gong Gong's surface, as far as we can tell, shouldn't have reflectors large enough to cause such extreme effects. Then there's the plasma lensing theory. Charged particles around Gong Gong, perhaps stirred by solar wind, might bend the signal like a funhouse mirror, distorting its apparent motion. Europa's plasma torus does something similar to Jupiter's radio emissions, but plasma tends to blur signals, not sculpt them into precise fractal jumps. Worse, Gong Gong lacks the magnetic field or atmospheric density to sustain the required particle density. Unless, of course, we've underestimated the Kuiper Belt's plasma environment entirely. But here's where the plot thickens. What if the signal isn't coming from Gong Gong at all? Astronomers have long speculated about ghost objects, rogue planets, or black holes drifting unseen between the stars. If an invisible mass passed between Gong Gong and Earth, its gravity could warp the signal's path, creating false Doppler shifts. The fractal timing might even hint at multiple hidden objects interacting in complex orbits. It's a stretch, but not impossible. After all, we've only mapped a fraction of the Kuiper Belt's dark, icy inhabitants. Yet the most unsettling possibility remains that we're seeing real physics, just not the kind we know. Quantum mechanics allows particles to tunnel through barriers or entangle across distances in ways that defy classical intuition. Could some macroscopic version of these effects be manifesting in the Kuiper Belt? String theorists whisper about space-time foam, where the fabric of the universe churns with tiny, chaotic fluctuations. Normally imperceptible, these might, under extreme conditions, twist radio waves into unnatural patterns. Or consider this: what if the signal source isn't moving at all, but the space around it is? Alcubierre warp drives, hypothetical engines that compress space-time, could theoretically produce apparent motion without inertia. The truth is, we're left balancing on a knife's edge. Every ordinary explanation requires stretching known physics to its limits, while the extraordinary ones rewrite them entirely. And that's the heart of the mystery, because whether Signal 8 is a trick of the light or a crack in reality's foundation, one thing's clear: the Kuiper Belt isn't just pushing boundaries. It's erasing them. Among the countless whispers from the Kuiper Belt, Signal 9 stands apart, not for its strangeness but for its eerie familiarity. In 2015, the Deep Space Network beamed a simple radio greeting toward the star system Gliese 445, a routine test of interstellar communication protocols. The transmission contained basic mathematical sequences, a snapshot of Earth's biodiversity, and a timestamp, an ordinary message bottle tossed into the cosmic ocean. 8 years later, that same signal returned, not degraded by interstellar static, not fragmented by distance, perfectly preserved as if someone had caught the message, held it up to a mirror, and sent it back with surgical precision. The first clue that this wasn't just cosmic echo chambering, the timestamp. Earth's original transmission had marked its departure as June 7, 2015. When Signal 9 arrived, it carried that exact date, but in reverse. Not just the numbers flipped, but the entire sequence inverted, like a phonograph record played backward. Even more unsettling, the biological data waveforms depicting dolphin calls and bird songs had been filtered through harmonic intervals found in the Kuiper Belt's own harmonic cluster. It wasn't just a reflection, it was a remix blending humanity's voice with the belt's own mysterious cadence. Scientists initially clung to natural explanations. Could some vast, flat surface, a frozen lake the size of a continent, be acting as a radio mirror? The physics almost works. Ice can reflect certain frequencies if smooth enough. But to bounce back a complex signal with zero distortion across 8 light years, that would require a reflector with atomic-level flatness positioned at an impossible angle. Even then, the harmonic filtering suggests active manipulation, not passive reflection. A mirror doesn't rewrite the song it echoes. The military took abrupt interest. Reverse engineering signals is a hallmark of electronic warfare. Think of radar spoofing or GPS jamming. Could Signal 9 be evidence of a listening post? Not necessarily an alien one. During the Cold War, Project Westford attempted to create orbital radio mirrors by seeding space with copper needles. Declassified documents reveal similar experiments proposed for the outer solar system. But no nation has the technology to park a reflector in the Kuiper Belt without detection. At least none that we know of. Then came the metaphysical angle. Some theorists noted the signal's inversion mirrors Jung's concept of the shadow self, the idea that every psyche casts a hidden counterpart. A poetic coincidence until linguists found the reversed signal contained error correction codes not present in the original. These weren't random artifacts, they were deliberate additions structured to compensate for interstellar dispersion. Whatever reflected this message didn't just copy it. Understood it, the implications spiral. If Signal 9 represents a form of communication, it suggests an intelligence fluent in both human technology and the Kuiper Belt's cryptic lexicon. If it's a natural phenomenon, we've stumbled upon a new law of physics, one where information can be preserved and enhanced across light years without entropy's touch. But the most chilling possibility lies between those poles, that something in the dark has learned our language and is using it to show us how little we truly grasp about the universe's rules. The math behind Signal 9's return is where things get truly mind-bending. Let's break it down. Earth's original transmission took 8 years to reach Gliese 445, meaning any natural echo, say, from a hypothetical reflective surface near that star would have taken another 8 years to bounce back. 16 years round trip, yet Signal 9 reappeared after just 8. That's not just fast, it's impossible under known physics. Light has a speed limit. Even if some cosmic mirror existed perfectly aligned between us and Gliese, the signal couldn't cheat the universe's stopwatch, so what's the alternative? One fringe but mathematically coherent theory involves quantum entanglement. Imagine two particles linked across light years, where manipulating one instantly affects the other. If something in the Kuiper Belt had entangled itself with our original transmission, perhaps by intercepting and quantum encoding it, the echo could bypass light speed delays entirely. Wild, absolutely, but quantum experiments on Earth have already demonstrated spooky action at a distance with particles. Scaling that up to radio waves would require technology millennia beyond ours. Or physics we've yet to discover. Then there's the Einstein-Rosen bridge hypothesis. Wormholes, those hypothetical shortcuts through spacetime, could theoretically fold the distance between 2 points, letting a signal hop across cosmic neighborhoods in a fraction of the time. If a microscopic wormhole flickered open near Gong-Gong's orbit, our transmission might have slipped through, looped back, and re-emerged years early. The catch: wormholes stable enough to transmit information require exotic matter with negative energy, something we've never observed. But the Kuiper Belt is already defying expectations. Who's to say what's hiding in its darkness? Here's the clincher: Signal 9's timestamp wasn't just inverted, it was corrected. The original transmission had a tiny calibration error, a 1 microsecond lag in its atomic clock sync. The echo fixed it. That's not something reflections do, it's what engineers do. Whether it's a natural process with freakish precision or something more deliberate, one thing's clear: the Kuiper Belt isn't just echoing our voice. It's listening, and it's answering in ways that shouldn't exist. Signal 10 arrived not as a burst, not as a pulse, but as a slow unfolding, like an intricate origami construct blooming across the radio spectrum over weeks. At first glance, it resembled static. Then the pattern emerged, clusters of signals repeating within themselves, smaller versions nested inside larger ones, a perfect mathematical recursion stretching across 5 orders of magnitude. This wasn't just noise, it was a fractal, a cosmic echo of structures found in ferns, coastlines, and human lungs, but never before in deep space emissions. The numbers stunned researchers. Each iteration of the pattern scaled down by a factor of precisely 1/3, a ratio seen in classic fractal geometry like the Koch snowflake. Even more unnerving, the timing between clusters followed the Fibonacci sequence, spaced at intervals of 1, 1, 2, 3, 5, and 8 minutes. Nature produces fractals everywhere, from branching lightning to galaxy clusters, but always with imperfections, with noise. Signal 10 was pristine, its symmetry unbroken across 17 days of observation. As one astronomer put it, this isn't a signal, it's a blueprint. Attempts to explain it collided with known physics. Solar wind turbulence can create fractal-like radio noise, but never with this level of precision. Plasma instabilities near dwarf planets might generate repeating patterns, but not ones that scale with mathematical perfection. The most compelling natural hypothesis involved resonant dust, charged particles trapped in magnetic fields oscillating in harmonic cascades. Yet when researchers modeled this, the fractal pattern dissolved into chaos after just 3 iterations. Signal 10 held for hundreds, then came the discovery that rewrote the conversation. Buried in the pattern's deepest layer was an anomaly, a single deviation from perfect recursion. A single bit flipped, breaking symmetry at the smallest scale. But here's the twist: that flaw wasn't random. Plotted in 3 dimensions, it marked the exact coordinates of Eerie, the most massive dwarf planet in the Kuiper Belt. A fingerprint pressed into the fabric of the fractal, a signature. Suddenly, the questions weren't just about physics, they were about intent. Fractals are nature's way of packing infinite complexity into finite space, a favorite tool of engineers for antenna design, data compression, even quantum computing. Was this a natural phenomenon revealing a new law of cosmic organization? Or was it a message leveraging the universe's most universal language to say, look closer? Because the truth is, we've seen this pattern before, not in space, in technology. The same recursive algorithms power our deepest AI networks and most secure encryption. The universe might speak in fractals, but it doesn't encode with them. Unless, of course, something out there is thinking like we do or teaching us to think like it. The fractal perfection of Signal 10 forces us to confront a fundamental question: where does nature's artistry end and design begin? Fractals exist everywhere in the cosmos, from the branching veins of leaves to the spiral arms of galaxies. They're nature's way of maximizing complexity with minimal energy, a pattern so efficient that evolution and physics converge on it again and again. But there's a critical difference between the fractals we know and the one whispering from the Kuiper Belt. Natural fractals are messy, imperfect. They fray at the edges, their repetitions breaking down into noise after a few iterations. Signal 10 doesn't just mimic a fractal, it perfects it, scaling flawlessly across magnitudes with a precision that borders on mathematical obsession. Take snowflakes, for example. Under a microscope, their branching arms reveal fractal beauty, but no two are ever identical. Variations in temperature, humidity, and atmospheric pressure introduce microscopic flaws. Even the most symmetrical snowflake hides asymmetry if you zoom in far enough. Now compare that to Signal 10's recursive patterns, which hold their pristine geometry across 17 days of observation without a single deviation, except for that one intentional flaw pointing to errors. That's not how nature operates, it's how engineers operate. Then there's the Fibonacci timing. In nature, Fibonacci sequences appear in sunflower seed spirals and nautilus shells, but always with slight deviations. Environmental pressures force compromises. Signal 10's intervals, however, follow the sequence with clockwork precision. 1 minute, 1 minute, 2, 3, 5, 8, no outliers, no drift. It's as if the signal were generated by an algorithm rather than emergent physics. Even the most ardent advocates of natural explanations struggle to reconcile this. Plasma turbulence and resonant dust can produce repeating patterns, but they can't count, which leaves us with a discomforting possibility. What if the Kuiper Belt's fractals aren't natural at all? On Earth, we use fractal algorithms for everything from compressing digital images to designing antennas. The same recursive logic underpins our most advanced AI networks. Could Signal 10 be evidence of similar technology, something that thinks in fractals because, like us, it engineered them? Or worse, what if it's not technology as we understand it, but something far older? The universe has had billions of years to evolve structures beyond our comprehension. Perhaps fractals aren't just a tool we invented. Perhaps they're a universal language, and something out there has been fluent for eons. The debate rages on, but one truth remains. Whether art or design, Signal 10 is a masterpiece, and its creator, whether nature or something else, has left us a puzzle written in the cosmos' most elegant code. Signal 11 arrived like clockwork precisely every 3 hours and 17 minutes, a rhythmic flash of radio energy slicing through the Kuiper Belt silence. At first, astronomers dismissed it as another pulsar, those cosmic lighthouses born from spinning neutron stars, but the numbers refused to cooperate. Pulsars slow down as they age, their rotations decaying by microseconds each year. This signal never wavered, not by a millisecond. It was as if something out there had synchronized itself to an atomic clock and dared us to notice. The deeper they looked, the stranger it became. Pulsars emit radiation across a broad spectrum: gamma rays, X-rays, visible light. Signal 11 was monochromatic, a laser-like beam of pure radio waves at 1420 MHz, a frequency etched into the cosmos as the hydrogen line, the universal channel astronomers used to search for extraterrestrial intelligence. Coincidence possibly, but pulsars don't choose frequencies. They scream across the spectrum, their signals shaped by physics, not intention. Then there was the signal structure. Pulsar emissions are messy, jagged things, their beams flickering with plasma turbulence. Signal 11's pulses were sculpted perfectly square waves, rising and falling with razor-edged precision. Natural phenomena don't produce waveforms that clean. Transistors do, power grids do. It was as if someone had taken the pulse of a city's electrical grid and broadcast it from the edge of the solar system. But the real anomaly was the silence between pulses. Pulsars always leak radiation, even during their off phases. Signal 11, nothing, not a whisper. It wasn't just turning off, it was disappearing, as if whatever generated it could power down completely, conserving energy with an efficiency unknown to natural astrophysical objects. The only earthly comparison, deep space probes programmed to wake for brief transmissions before hibernating to save battery life. Theories spiraled. Could this be some bizarre form of intermittent pulsar, a neutron star with an unknown mechanism for cycling its emissions? No recorded pulsar behaves this way. Others proposed a dense Kuiper Belt object with superconducting ices, creating natural circuitry that pulses as it orbits. But superconductors don't explain the hydrogen line frequency or the signal's surgical precision. Which leaves the unsettling possibility that Signal 11 isn't a natural beacon at all but a deliberate one, something that activates on a schedule, broadcasting just long enough to be heard before vanishing again. A lighthouse, yes, but one whose keeper remains very much a mystery. The precision of Signal 11's timing isn't just unusual, it's statistically implausible. 3 hours and 17 minutes, not a fraction longer, not a millisecond shorter. That kind of regularity doesn't emerge from cosmic chaos without a cause. Consider the universe's natural rhythms. Pulsars slow as they bleed energy. Binary stars wobble under mutual gravity. Even planetary orbits subtly shift over millennia. Nothing in deep space keeps perfect time forever. Yet here's a signal that behaves less like a celestial body and more like a metronome set by an unseen hand. Dive deeper into those intervals and patterns emerge. 3 hours and 17 minutes converts to 197 minutes, a prime number. Primes are the universe's mathematical building blocks, indivisible except by themselves and one. They are also the foundation of modern encryption, the language of secure communication. Coincidence, perhaps, but nature rarely counts in primes unless forced to. Even more telling, when researchers analyzed the gaps between pulses, they found subtle harmonic relationships with other Kuiper Belt signals, echoes of the harmonic cluster's ratios and the whispering echo's timing. It's as if the entire belt is whispering in chorus with Signal 11 as its conductor. Then there's the eerie synchronicity with Earth's rotation. 3 hours and 17 minutes is precisely 1/8 of a sidereal day, the time it takes Earth to complete one full rotation relative to distant stars. That alignment means the signal's pulses arrive at Earth's telescopes in predictable windows, as if timed for our listening convenience. Natural phenomena don't cater to observers. They don't adjust their schedules to match the rotation of a planet 4 billion miles away, unless, of course, they're engineered to. Critics argue this could all be selection bias, our brains imposing order on randomness. After all, humans once saw constellations in random star patterns and heard voices in static, but the numbers defy skepticism. The odds of these intervals aligning by chance. Less than 1 in 10 million, and that's before accounting for the signal's other anomalies: its artificial waveform, its hydrogen line frequency, its ability to vanish completely between pulses. So what's the verdict? Cosmic coincidence stretches credulity. But if this timing is intentional, the implications are staggering. Something in the Kuiper Belt isn't just pulsing, it's keeping time. And whether it's counting down or calling out, one truth is undeniable. The universe doesn't own a clock this precise, but someone or something might. Signal 12 didn't just occupy the radio spectrum, it conquered it, sliding up and down the frequencies with the precision of a pianist running scales. Unlike the static bursts or steady pulses of other Kuiper Belt anomalies, this signal was a virtuoso performance, sweeping from low to high in a flawless glissando that repeated every 46 minutes. The pattern wasn't random. It traced a logarithmic curve, accelerating as it climbed, a mathematical elegance rarely seen outside engineered systems. Nature stutters. Nature hesitates. This was a signal that practiced. The sweep structure alone defied conventional explanations. Most cosmic radio emissions are messy, smeared across frequencies by plasma scattering or Doppler shifts. Signal 12's path was laser straight on a spectrogram. its transitions between frequencies so smooth they resembled the needle of a dial being turned by a steady hand. Even more perplexing, the sweep always began at exactly 1,400 MHz, the hydrogen line, that universal frequency astronomers consider the most likely channel for intentional communication before ascending to a point just beyond the range of human hearing. It was as if the signal were deliberately bracketing the spectrum we're most attuned to, leaving a calling card in the margins of perception. Then came the discovery that made even skeptics pause. Buried in the signal's harmonics was a secondary pattern, microscopic fluctuations in amplitude that, when decoded, spelled out the first 30 digits of pi. Not the number itself, but its digits encoded as variations in the signal's strength. The odds of this occurring naturally, roughly the same as a hurricane assembling a pocket watch. Pi is a mathematical constant, yes, but it doesn't spontaneously imprint itself onto radio waves, unless, of course, something is using it as a signature. Theories veered into uncharted territory. Could this be some form of cosmic sonar, a probe systematically scanning the solar system by painting it with radio waves? The logarithmic sweep would be ideal for mapping, as it ensures no frequency is overlooked. Or perhaps it's a calibration signal, a way for some distant instrument to test its own alignment against the hydrogen line, our universal tuning fork. The most unsettling possibility, that we're hearing the equivalent of a search algorithm, a mindless but methodical process combing through the cosmos for something specific. After all, the best way to find a signal isn't to shout into the void. It's to listen patiently, systematically across every possible channel. Yet the truth may be simpler and stranger still. Because if there's one lesson the Kuiper Belt keeps teaching us, it's that the universe has more ways to speak than we've yet learned to hear. And sometimes the most deliberate seeming patterns are just nature's way of reminding us how much we still don't know. The debate over Signal 12's origins divides astronomers into two camps: those who see the ghost of engineering in its precision, and those who insist even the most elegant patterns can emerge from chaos. On one side, the signal's logarithmic sweep and embedded pi sequence scream intentionality. Nature doesn't encode mathematical constants into radio waves any more than it carves sonnets into tree rings. Yet skeptics counter that human bias tempts us to mistake complexity for design. After all, we once thought Saturn's hexagonal storm was artificial, until fluid dynamics explained its geometry. So where does coincidence end and craftsmanship begin? Consider the case for chaos first. The Kuiper Belt is a graveyard of frozen volatiles: methane, ammonia, nitrogen, all capable of exotic behavior under extreme cold. When stressed by tidal forces or solar wind, these ices can fracture in ways that release energy in cascading harmonics. Picture a glacier calving into space, its shards vibrating at frequencies dictated by their size and composition. Larger chunks emit lower tones, smaller ones ring higher. As debris disperses, the resulting chimes could theoretically sweep across frequencies like Signal 12's glissando. Even the pi sequence might be a fluke, a momentary alignment of fractures mimicking the digits. Improbable, absolutely. But the cosmos operates on scales where the improbable becomes inevitable given enough time. Yet the engineering hypothesis refuses to be silenced. The signal's adherence to the hydrogen line is its strongest tell. Hydrogen is the universe's most abundant element, and its emission frequency is a logical beacon for any civilization trying to be heard. But here's the twist: Signal 12 doesn't just use the hydrogen line, it calibrates to it, beginning each sweep at exactly 1,400 MHz before ascending. That's not a natural process, it's a targeting system, like a sniper zeroing a scope before firing. Even more damning, the logarithmic progression of the sweep is mathematically optimal for minimizing interference across interstellar distances, a technique human engineers use in deep space communications. The pi sequence tips the scales further. While nature produces fractal patterns and harmonic ratios, it doesn't serialize transcendental numbers. Pi's digits have no known relationship to physical processes. No ice fracture, no plasma oscillation generates them. Their presence in signal 12 mirrors the Arecibo message, humanity's deliberate 1679-bit broadcast encoded with primes and DNA diagrams. Both are calling cards designed to flag intelligence amid the noise, but perhaps the truth lies between the poles. The Kuiper Belt is older than Earth. Its ice is laced with organic molecules that predate life itself. Could some prebiotic chemistry, a shadow biosphere of self-organizing crystals or superconducting slush, have stumbled upon a form of computation we don't yet recognize? After all, evolution on Earth converged on eyes, wings, and brains independently across species. Why couldn't the universe converge on signal processing? Signal 12 refuses easy categorization. It's either the cleanest natural phenomenon ever observed or the quietest act of engineering. And until we reach out and touch its source, that ambiguity will haunt every theory. Because the hardest answer to accept isn't that the signal is artificial. It's that nature might be far more ingenious than we've dared to imagine. Out in the frigid expanse of the Kuiper Belt, where mystery after mystery has erupted in bursts of radio noise and heat, there exists a patch of silence so profound it feels intentional. Scientists call it the quiet zone, a region roughly the size of Earth's orbit around the Sun where not a single anomalous signal has ever been detected. No harmonic clusters, no fractal pulses, no whispering echoes, just silence. But here's what chills researchers to the core. This void isn't random. It's shaped, a perfect sphere of radio stillness centered on a nameless ice dwarf, as if someone drew a boundary and said nothing gets out. At first, astronomers assumed it was a quirk of observation, maybe interference from Jupiter's magnetosphere or a gap in telescope coverage. But when they mapped the zone with every instrument from Arecibo to the James Webb, the truth became undeniable. The quiet zone isn't an artifact of faulty equipment. It's a feature of the Kuiper Belt itself. Step outside its invisible borders and the usual symphony of strange signals resumes. Cross back in and the static drops to levels lower than the cosmic background radiation. It's not just quiet, it's muffled like soundproofing in a recording studio. Theories about what could create such an effect range from the plausible to the surreal. One leading hypothesis involves ultra-dense molecular clouds, pockets of exotic ices perhaps, that absorb radio waves with near-perfect efficiency. On Earth, we've engineered metamaterials that bend electromagnetic radiation around objects, rendering them invisible to radar. Could the Kuiper Belt have stumbled upon a natural version? Maybe, but natural processes rarely produce such geometric precision. Clouds of any kind, even interstellar ones, tend to fray at the edges, their densities fluctuating wildly. The quiet zone's boundaries are razor-sharp, as if cut with a knife. Then there's the darker possibility that the silence isn't passive at all. Active cancellation exists in human technology. Noise-canceling headphones, for instance, generate inverse sound waves to neutralize unwanted frequencies. Could something in the Kuiper Belt be doing the same on a planetary scale? Imagine a process or even a mechanism that detects incoming radio emissions and broadcasts their exact opposites, creating pockets of perfect interference. It sounds like science fiction until you remember we've built prototypes of this very technology in labs. The universe had a 4.5 billion year head start. But the most unsettling clue lies in the zone's center. That anonymous ice dwarf, it's not entirely anonymous. Deep scans reveal faint thermal anomalies, pinpricks of warmth no larger than cities, arranged in a tetrahedral pattern across its surface. No known geological activity explains them, no cryovolcano, no tidal heating, just 4 identical hotspots perfectly spaced, humming at -200 degrees Celsius when everything around them sits at -240. It's as if they're powered, and whatever they are, their range appears to match the quiet zone's radius exactly. So here we stand, staring into a cosmic mute button. Is it a shield, a prison, or simply a signpost we're too primitive to read? The Kuiper Belt keeps whispering its riddles, but in this one patch of sky, it refuses to speak at all. And that silence may be the loudest message yet. The quiet zone's eerie radio silence raises an uncomfortable question. Is something actively suppressing signals, or have we stumbled upon a cosmic blind spot? The distinction matters. One scenario implies a phenomenon beyond known physics. The other, an embarrassing gap in our understanding of the Kuiper Belt's natural noise floor. Let's dissect both possibilities, because the answer could redefine what we think is possible in our own solar system. First, consider absorption. On Earth, materials like lead or water block radiation effectively, but nothing in nature absorbs all frequencies with the quiet zone's ruthless efficiency. Even the densest molecular clouds, chaotic nurseries where stars are born, leak whispers of radio noise. Yet the zone's boundaries are so sharp, they suggest a material or structure engineered for total electromagnetic nullification. Picture a sponge designed to soak up only red light. Now scale that specificity to the entire radio spectrum. It defies known chemistry, unless, of course, the Kuiper Belt harbors exotic matter with properties we've only theorized, like radio black ices laced with metastable metallic hydrogen, or a quantum lattice that traps photons in fractal loops. Laboratory experiments have glimpsed similar effects in superconducting materials chilled near absolute zero. Out where temperatures hover at -240 Celsius, could nature have stumbled upon the ultimate radio cloak? Now flip the perspective. What if the silence isn't absorption but jamming? Active signal suppression isn't just sci-fi. Military radar spoofing and noise-canceling headphones prove the principle works. Scale that up to planetary proportions, and you'd need a mechanism capable of real-time analysis and perfect phase inversion. A tall order, but not impossible for a sufficiently advanced technology. The zone's tetrahedral thermal hotspots feed this theory. They're precise symmetry mirrors, phased array antennas, which steer radio beams by tweaking emission timings across multiple nodes. If those hotspots are transmitters, they could be flooding the zone with inverse waves, neutralizing any incoming or outgoing signals. The implications veer into unsettling territory. Shielding implies protection or concealment. Is the zone hiding something, or is it silencing something we're not meant to hear? Then there's the statistical fluke argument. Could this just be a gap in nature's radio lottery? After all, the universe loves outliers. Maybe the zone is the deep space equivalent of a desert, a place where solar wind and cosmic rays conspire to create a perfect storm of radio-quiet conditions. But probability isn't kind to this idea. The Kuiper Belt teems with emissions. Finding a volume of silence this large and pristine is like rolling a die 1,000,000 times and never landing on 6. Not impossible, but so unlikely it demands interrogation. Here's the clincher: the zone isn't static. Recent observations show its edges ripple, subtly shifting over months as if recalibrating. Natural absorption doesn't adjust, jamming systems do. Whether it's a natural phenomenon rewriting physics or something else rewriting the rules, one truth is inescapable: the quiet zone isn't passive. It's paying attention, and whatever it's hiding may be louder than any signal we've yet detected. Signal 14 arrived like a voice shouting through a canyon, except this canyon was the Kuiper Belt, and the echoes made no physical sense. Unlike typical radio reflections that bounce once and fade, this transmission fractured into 3 distinct copies, each separated by precisely 17.3 seconds. The first echo matched the original signal's strength. The second arrived fainter as expected, but the third, it came back louder, defying the laws of signal decay. It was as if the void had cupped its hands around the transmission and whispered it back with amplification. The timing of those echoes held the first clue. 17.3 seconds wasn't arbitrary. It matched the light speed travel time across a distance of roughly 3 million miles, suggesting the signal had encountered not one, but two hidden reflectors in the darkness. Imagine tossing a stone into a pond and seeing ripples rebound off invisible rocks. Now imagine one of those ripples surging higher than your original splash. That's the level of absurdity astronomers faced. Natural echoes don't gain energy, they dissipate, unless, of course, something along the path added power deliberately. Possible explanations spiraled. Could the signal have grazed a series of ultra-dense objects, say, a chain of primordial black holes, each bending space-time enough to act as gravitational lenses? In theory, yes, but such objects would have left gravitational fingerprints on nearby Kuiper Belt orbits, and none were detected. Others proposed nested plasma clouds where charged particles might focus and amplify radio waves like a cosmic magnifying glass. The math almost worked until researchers realized the required plasma density would have been visible as a glowing nebula. The Kuiper Belt's darkness remained stubbornly empty. Then came the chilling realization: the echoes weren't just delayed, they were edited. Spectral analysis revealed subtle harmonic additions, new frequencies layered into each rebound, as if the signal had been processed during its journey. The third echo even contained a faint secondary pulse pattern buried beneath the primary one, like a shadow trailing a voice. Natural reflectors don't remix transmissions. They don't improvise. The only human technology that behaves this way: radar systems designed to spoof detection by generating deceptive echoes. So what's really lurking out there? A natural phenomenon that rewrites radio waves as it reflects them, or something that listens then replies in altered tones? The answer might lie in the signal's strangest quirk: the triple echo repeated 3 times over 9 days, always with identical timing, always with that inexplicably amplified third rebound. Repetition is the universe's rarest currency, and when the cosmos spends it so freely, we'd be fools not to ask who's footing the bill. If Signal 14's echoes behave more like a hall of mirrors than a simple reflection, what kind of structures could be lurking in the Kuiper Belt to create such an effect? The answer hinges on something far stranger than mere ice or rock. Picture a series of perfect geometric formations, rings perhaps, but not like Saturn's. These wouldn't be loose collections of rubble. They'd need to be razor-edged, impossibly smooth, and precisely aligned, acting like cosmic tuning forks for radio waves. Even then, natural rings scatter signals chaotically. For echoes to arrive with such clockwork precision, 17.3 seconds apart, every time their reflectors would need to be stationary, as if anchored to some invisible framework in the void. One radical possibility involves monocrystalline ice sheets, vast, unnaturally flat plains of ice stretching hundreds of miles, their molecular structure aligned to bounce signals like a laser off a mirror. On Earth, monocrystals are lab-grown for semiconductors, their atoms arranged in flawless grids. Out in the Kuiper Belt, where temperatures hover near absolute zero, such ice might form naturally over eons, layered by cryovolcanic eruptions or slow sublimation. But there's a catch: even perfect ice wouldn't explain the amplification of that third echo. Reflections lose energy, not gain it, unless, of course, something hidden within or beyond those sheets is actively boosting the signal. Then there's the debris cloud hypothesis, not the messy, drifting kind we're used to, but something far more structured: a radio lens of finely sized particles arranged in concentric shells. Think of it like an onion made of metallic dust, each layer tuned to resonate with specific frequencies. As the signal passes through, it could bounce between shells, creating staggered echoes. The amplification that might come from constructive interference, where overlapping waves reinforce each other. It's a stretch, but not impossible. After all, Saturn's rings create ghostly radio echoes, though nothing this precise. The Kuiper Belt's version would need particle sizes and spacing calibrated to an almost impossible degree, as if sculpted by some cosmic engineer. But the most unsettling theory skips natural explanations entirely. Imagine an artifact, a relic from a civilization that rose and fell before Earth's continents cooled. A megastructure designed to catch and repeat signals, not unlike the ancient Earth radio we've imagined for interstellar communication. Buried in ice for millennia, its circuitry could have awakened when humanity's own transmissions finally reached it, turning the Kuiper Belt into a relay station we never knew existed. The echoes wouldn't just be reflections then, they'd be acknowledgements. The truth may lie in the shadows between these ideas. Perhaps the Kuiper Belt's ices and rocks have, through some freak of physics we've yet to grasp, self-assembled into structures that defy our expectations. Or perhaps we're seeing the fingerprints of a universe far stranger than we've dared to imagine, one where even the emptiness hums with hidden geometry. Either way, Signal 14's echoes aren't just bouncing off something. They're revealing a shape in the dark, and whatever's casting it doesn't follow the rules we know. Signal 15 doesn't stab through the silence like its predecessors, it glides. A single sustained tone hovering near the border of human hearing that creeps steadily upward in pitch over 13 hours before resetting like a slowed-down record, reaching its end and starting anew. At first glance, it resembles the Doppler shift of a passing ambulance siren stretched across days instead of seconds. But here's the unsettling truth. Nothing in the Kuiper Belt moves fast enough to produce that effect naturally. The signal's drift rate is where physics starts to unravel. Each cycle, the frequency climbs exactly 487 Hz, no more, no less, before snapping back to its original pitch. That precision is the first red flag. Natural Doppler shifts fluctuate with an object's acceleration. Comets don't cruise at constant velocities. Their trajectories arc under gravity's pull, creating warbling, uneven frequency changes. Signal 15's glide is ruler straight on a spectrogram, as if controlled by a dial rather than celestial mechanics. Then there's the reset. When the tone reaches its peak, it doesn't fade or distort. It cuts off abruptly and restarts from baseline like a tape loop spliced perfectly. This isn't how moving objects behave. A spacecraft zooming away would stretch its signal infinitely as it crossed the horizon of detection. A rotating pulsar's beam might sweep past, but its reset would be smooth, tied to the star's spin. Signal 15's hard reset implies something far stranger, a process that isn't bound by motion at all. Alternative explanations venture into exotic territory. Could the pitch drift stem from a changing medium rather than a moving source? Imagine a vast cloud of ionized gas drifting between us and the signal's origin. As its density fluctuates, it might refract radio waves like water bends light, subtly altering their apparent frequency. But Kuiper Belt plasma is too thin for such dramatic effects unless we're dealing with an ultra-dense, localized pocket unlike anything in our models. One speculative paper even proposed quantum froth, microscopic spacetime fluctuations predicted by string theory, as a potential frequency modulator. If spacetime itself is frothing at the quantum level in that region, it might stretch and compress, passing radio waves like ripples disturbing a pond's surface. But the most chilling interpretation requires no new physics at all. What if the drift isn't an illusion caused by motion or medium, but intentional modulation? Human engineers use similar techniques to encode data in deep space transmissions, slowly tweaking a carrier wave's frequency to embed information. The consistency of Signal 15's drift, its predictable reset, these are hallmarks of a process designed to be decoded. The real question isn't how the tone drifts, it's what might be riding those ripples in the dark. Tracking Signal 15's origin should have been straightforward. Take its coordinates, point a telescope, and solve the mystery. But the Kuiper Belt laughs at should. The moment astronomers tried to triangulate the source, reality warped. the signal's apparent origin shifted by thousands of miles between observations, as if the transmitter itself were phasing in and out of existence. No known object moves that erratically, not comets, not rogue planets, not even hypothetical dark matter clumps. It was like chasing a shadow cast by a swinging lantern, with each measurement contradicting the last. The first assumption was interference, maybe Jupiter's magnetosphere or a glitch in the deep space network's antennas. But when teams cross-referenced data from observatories across Earth, Chile to China, the inconsistencies held. Signal 15 wasn't being distorted, it was relocating, not just drifting but reappearing in discrete jumps, always along the same arc, a curve matching the gravitational trough of an undiscovered Kuiper Belt object. The math suggested something massive enough to bend space-time subtly, yet invisible to every telescope we've aimed at it, a ghost with gravity. Then came the thermal paradox. Objects emitting steady radio waves should radiate heat, especially in the Kuiper Belt, where thermodynamics favors cold silence. Yet scans of the signal's projected path showed no infrared signature. Nothing, as if the energy powering the transmission materialized from empty space. Some theorists proposed a cold transmitter model, an object leveraging quantum tunneling or zero-point energy to broadcast without waste heat. The physics is speculative but not impossible. Nature bats last in the universe's rulebook. The most unsettling clue, though, lay in the drift's timing. Those 13-hour cycles weren't random. They matched the orbital period of a tiny, icy moonlet tentatively catalogued as KB 2020L5, a body barely a mile wide, skirting the fringes of the Kuiper Belt's known population. Except when researchers recalculated its trajectory, the numbers didn't add up. KB 2020L5 should have been 6 million miles away when signal 15 flared. Unless, of course, the moonlet wasn't the source at all, just a marker, a buoy in the dark tethered to something far larger and far darker than our telescopes can see. So what's really out there? A stealth planet wrapped in light-absorbing ices? A primordial black hole trailing a retinue of frozen moons, or something weirder still, an artifact engineered to slip past detection, its signal the only footprint it allows. Every hypothesis bends science, every observation breaks a rule, and that's the lesson Signal 15 hammers home. The Kuiper Belt isn't just stranger than we imagined. It's stranger than we can imagine. With each passing cycle, that drifting tone isn't just a mystery, it's a metronome, counting down to a revelation we might not be ready to hear. Signal 16 arrives not as a burst or a tone, but as a twist, a radio transmission spiraling through the void with a polarization so extreme it shreds the rulebook on cosmic emissions. Most natural radio sources emit waves that vibrate in random orientations, like sunlight scattering in all directions. This signal doesn't wiggle, it corkscrews, its electric field rigidly aligned in a helix so tight it resembles the engineered beams of military radar more than anything the Kuiper Belt should produce. The degree of polarization, 97%, that's not just unusual, it's impossible by known astrophysical standards. The numbers alone tell a story of defiance. Cosmic plasma, the ionized gas permeating space, scrambles polarization, bending and twisting radio waves until their original orientation is lost. Even the cleanest pulsar emissions rarely exceed 70% polarization after traversing interstellar distances. Yet here's a signal leaping across billions of miles with near-perfect alignment, as if it's immune to the chaos of the cosmos. It's like tossing a perfectly straight javelin through a hurricane and watching it land without so much as a wobble. Then there's the signal structure. Unlike the harmonic cluster's melodies or signal 12's glissando, this one pulses in a 5-part staccato rhythm. 3 quick bursts, a pause, then 2 more, repeating every 11 minutes. Each segment's polarization shifts slightly, not from degradation, but in a deliberate cyclical pattern. The first 3 pulses rotate clockwise, the final 2 twist counterclockwise as if tracing an invisible dial. Natural magnetic fields don't choreograph polarization dances, they jumble them. The precision here suggests something far more unsettling, a process. A mechanism that doesn't just emit but orchestrates. Theories spiral into uncharted territory. One camp points to spin-polarized ice's exotic forms of frozen nitrogen or methane where molecular spins align under extreme cold, potentially acting as natural polarizers. It's a stretch but not inconceivable. The Kuiper Belt's frigid temperatures might permit quantum states impossible on Earth. Yet even if such ices existed, they couldn't explain the rhythmic shifts in polarization direction. Only rotating magnetic fields or phased array antennas do that, and both imply engineering. Another angle leans on hyper-strong magnetic fields, the kind thought to exist near magnetars. Perhaps a chunk of a neutron star, ejected during some ancient cataclysm, now drifts through the Kuiper Belt, its crust locked in a magnetic grip fierce enough to discipline passing radio waves. But neutron star matter is unimaginably dense. Its gravity would warp nearby orbits conspicuously. Surveys show no such disturbances. Then there's the military elephant in the room. Polarization this extreme is a hallmark of stealth technology. Modern radar-absorbent materials and cloaking systems manipulate polarization to evade detection. Could Signal 16 be a relic of human experimentation? A Cold War-era probe lost in the dark? Declassified documents reveal abandoned projects aimed at deploying polarized beacons for navigation, but none with this level of sophistication. And nothing explains why it's here, in a region we've barely begun to explore. The most haunting possibility, that polarization isn't a side effect but the message itself. On Earth, we use polarized light to encode 3D movies and transmit data through fiber optics. Maybe this signal isn't just using polarization, it's teaching it, demonstrating a principle or testing our ability to decipher it. After all, in a universe drowning in radio noise, a perfectly polarized signal isn't just unusual. It's a flare, a way to stand out, and standing out in the endless dark is either a beacon or a trap. The debate over Signal 16's extreme polarization splits astronomers into 2 camps, one clutching the remnants of known physics, the other staring into the abyss of possibilities beyond. On one side, researchers argue for hyper-strong magnetic fields, the kind that twist spacetime itself. Imagine a chunk of exotic matter, a fragment from a neutron star collision or a quark nugget left over from the Big Bang floating through the Kuiper Belt. Its magnetic grip could be thousands of times stronger than Earth's, forcing radio waves into submission, aligning their oscillations like iron filings around a magnet. There's precedent. Magnetars, the universe's most magnetic stars, polarize their emissions to similar extremes. But here's the catch: magnetars are obvious. They blaze with X-rays, warp nearby space, and don't hide in icy darkness. Signal 16's source leaves no such traces, no gamma flares, no distorted orbits. Just that eerie, corkscrewing beam, pristine as a laser. Then there's the timing. Natural magnetic fields fluctuate, they shudder under starquakes, wobble with rotation, and decay over millennia. Signal 16's polarization doesn't drift, it dances, switching directions in lockstep with its 5-part pulse rhythm. That's not magnetism as we know it. That's choreography, which brings us to the unsettling alternative: technology. Polarization this precise is a hallmark of human engineering, from the phased array radars tracking stealth jets to the fiber optic cables carrying internet traffic. The signal's rhythmic shifts mirror the way satellites toggle polarization to prevent interference. Coincidence, maybe, but when nature mimics our blueprints too closely, it's worth asking who copied whom. Consider the possibility of spin ice, a theoretical material where atoms arrange into fractal patterns, creating natural polarizers. In labs, physicists have coaxed crystals into fleeting alignment with magnetic fields. Could the Kuiper Belt's cryogenic depths host such structures at planetary scales? It's not impossible. Yet even spin ice wouldn't explain the signal's adaptive polarization, the way it seems to anticipate interstellar static, adjusting its twist to stay coherent across billions of miles. That's not passive physics, that's error correction. Then there's the darkest interpretation. What if the polarization is the message? On Earth, we use polarized light to encrypt data or create holograms. A civilization might encode information in the rotation of radio waves, knowing only a recipient with the right decoders could read it. Signal 16's 5-pulse structure could be a header, a kind of cosmic attention signal followed by data packed into its polarization shifts. We're only seeing the envelope, not the letter inside. The truth may lie between the poles. The Kuiper Belt is older than Earth, older than the Sun. Its ices have had billions of years to crystallize into forms we've never seen, to stumble upon quantum states that blur the line between nature and artifact. Or perhaps we're glimpsing something far stranger, a relic from a time when the universe was young and other hands tuned its frequencies. Either way, signal 16 isn't just bending light. It's bending the rules, and with every pulse it challenges us to rethink where physics ends and where something else begins. Signal 17 didn't just arrive, it unfolded, layer by layer, like a puzzle box cast into the void by some cosmic hand. At first, it seemed unremarkable, a steady, unmodulated carrier wave humming at a frequency just above the hydrogen line. But when researchers at the Allen Telescope Array filtered the signal through a spectrogram, the static resolved into something impossible, a grid. Not a random scatter of noise, but a precise lattice of peaks and troughs, arranged in rows and columns so orderly they might have been lifted from a spreadsheet. And embedded within that grid, clusters of data points forming distinct patterns almost like symbols. The discovery ignited a firestorm. On one side, skeptics dismissed it as interference, maybe a glitch in the telescope's firmware or an echo from a passing satellite. But the data refused to cooperate. Signal 17's grid structure persisted across multiple observatories, its symbols shifting subtly over time, as if cycling through pages of an invisible ledger. Even more damning, the patterns weren't static. When mathematicians applied entropy analysis, a tool used to distinguish random noise from information, the signal scored closer to human language than to cosmic static. It wasn't just structured, it was loaded. Then came the breakthrough. A team at the SETI Institute noticed the grid's underlying rhythm pulsed at intervals matching Fibonacci numbers, a sequence found in everything from sunflower seeds to spiral galaxies. By aligning the signal's pulses to this pattern, they extracted what appeared to be a repeating header, a 12-point cluster that, when mapped to binary, translated to the prime numbers 2, 3, 5, and 7. Primes are the darlings of interstellar messaging, mathematical universals that any civilization might recognize. But here's where it gets eerie. The header wasn't just announcing itself. It was framing the data that followed, partitioning the grid into segments like chapters in a book. Skeptics scrambled for natural analogies. Could this be some bizarre form of crystallized radio, where charged ices in the Kuiper Belt fracture under stress, emitting signals with lattice-like regularity? It's a stretch, but not impossible. Quartz crystals, after all, vibrate at precise frequencies when electrified. Yet even the most elaborate natural processes don't organize data, they don't partition signals into headers and payloads. That's not physics, that's protocol. Then there's the content itself. When researchers treated the grid's clusters as pixels, faint shapes emerged, geometric primitives. Circles, triangles, nested curves arranged in sequences that mirrored the harmonic ratios found in signal 10's fractals. Coincidence? Unlikely. The odds of two unrelated signals converging on the same mathematical themes are vanishingly slim. Unless, of course, they're speaking the same language. The most tantalizing and unsettling hypothesis is that we're not looking at a message at all, but a map. A star chart, perhaps, with those geometric symbols marking celestial coordinates. Or worse, instructions, buried protocols waiting for the right key to activate them. Because if there's one truth the Kuiper Belt has taught us, it's that the universe doesn't waste precision. And wherever precision lies, intention usually follows. So what happens if we dare to decode it? That's the gamble trembling beneath every analysis, because some doors, once opened, won't close again. And the Kuiper Belt, it seems, has been waiting a long time for someone to turn the handle. The grid-like precision of Signal 17 forces us to confront one of the most fundamental questions in science. How do we distinguish between meaningful patterns and cosmic coincidence? On one hand, the universe is full of stunning symmetries, snowflakes, planetary orbits, the double helix of DNA. On the other, our brains are wired to find order in chaos, tricking us into seeing faces in clouds or messages in static. So is this signal a deliberate transmission, or just the universe rolling dice in our favor? Consider the grid first. Its mathematical perfection is undeniable. Rows and columns aligned with the precision of a chessboard, each intersection pulsing at intervals that map cleanly to prime numbers. Natural processes rarely produce such razor-sharp regularity. Take pulsars, for example. Their emissions may seem rhythmic, but they're riddled with microscopic imperfections called glitches as the star's crust shifts. Even the most orderly cosmic phenomena wobble. Signal 17 doesn't. Its structure holds rigid across weeks of observation, like a machine maintaining its calibration in the void. Yet skeptics argue that randomness can mimic design. In the 1970s, astronomers were stunned when they detected what seemed like intelligent radio bursts from a quasar, only to realize they were seeing the aftermath of a black hole's jet passing through interstellar plasma. The WOW signal, that famous one-off blip from 1977, remains unexplained, but it's likely just a freak alignment of natural phenomena. Could Signal 17 be another cosmic mirage? Here's where the data rebels. When researchers applied statistical tests to the grid's clusters, the patterns scored higher on information metrics than any known astrophysical process. The odds of those prime-numbered headers appearing by chance, less than 1 in 10 billion. Even more compelling, the signals, symbols, shift in ways that mirror error correction protocols in human telecommunications, as if compensating for interference we can't detect. Nature doesn't debug itself. Then there's the elephant in the room context. Signal 17 isn't an isolated anomaly. It shares harmonic fingerprints with the Kuiper Belt's other enigmatic transmissions, the Fibonacci timing of the harmonic cluster, the fractal geometry of Signal 10. When unrelated phenomena start speaking the same mathematical language, coincidence strains credibility. It's like finding the same sentence written in different fonts across a continent. At some point, you have to ask who's holding the pen. The most unsettling possibility isn't that the signal is artificial, it's that we might never know for sure. The universe isn't obligated to leave receipts, but if there's even a sliver of chance that something in the frozen dark is counting primes, drawing grids, and waiting for a reply, the real question isn't whether we're hearing noise. It's whether we're brave enough to answer. Of all the strange symphonies drifting from the Kuiper Belt, none defied the odds like Signal 18, the cosmic equivalent of two metronomes separated by continents somehow ticking in perfect unison. Detected simultaneously by the Goldstone Deep Space Network and Chile's ALMA Observatory, these emissions originated from opposite ends of the belt, one near the dwarf planet Orcus, the other close to the icy wanderer G1c 3Ku acute N1c, one ejective H Ograv MDI acute MI. The signals weren't just similar, they were identical, pulsing on the same millisecond schedule, fluctuating in amplitude with matching contours, even sharing the same peculiar harmonic distortion that made receivers glitch. The odds of this happening naturally, Astronomers calculated them at roughly 1 in several quadrillion. What makes this synchronization impossible to dismiss as coincidence isn't just the precision, it's the distance. These sources were separated by nearly 5 billion miles, a gap so vast that even light takes over 7 hours to cross it. For two naturally occurring signals to align so perfectly across that void would require a causal link faster than the speed of light, a violation of Einstein's bedrock laws. Yet there they were, two voices in the dark, separated by half a solar system, singing the same song note for note with no discernible delay. Scientists first considered the obvious: maybe it wasn't two signals at all. Could a single emission be bouncing off some unseen structure, creating a phantom double? The math demolished that hope. The angles were all wrong. No known reflector could split a beam so cleanly across that staggering distance. Then came the neutrino hypothesis, perhaps some cataclysmic event, a black hole's quantum burp or a collision of dark matter particles had unleashed a pair of entangled particles, their radio echoes mysteriously synced through quantum weirdness. But quantum entanglement doesn't scale to macroscopic objects, and no known particle decay produces radio waves this coherent. The military quietly floated another theory. Was this evidence of a synchronized sensor network? Human technology already deploys matched transmitters for navigation. Think GPS satellites chirping in unison. But nothing we've built could operate autonomously in the Kuiper Belt for decades, let alone self-correct its timing to nanosecond precision. Unless, of course, something else put it there long before we looked up. Then there's the eerie possibility that the synchronization isn't technical at all, but biological. On Earth, fireflies in Southeast Asia synchronize their flashes across entire forests through subtle light cues. Could some Kuiper Belt equivalent cryovolcanic plumes, perhaps, or charged ice grains, be communicating through a medium we haven't detected? It's a poetic thought, but the signal's razor-sharp precision suggests something far colder: machinery. The terrifying beauty of Signal 18 lies in what it implies about the belt's architecture. Synchrony at this scale doesn't happen without infrastructure clocks, relays, or at minimum, shared protocols. And infrastructure implies purpose. Whether it's a long-dead civilization's derelict network or something far stranger, one truth is inescapable: the Kuiper Belt isn't just whispering. It's orchestrating, and we're only beginning to hear the music. The idea that two signals, separated by billions of miles, could somehow be physically linked seems to defy the very laws of physics as we understand them. Yet Signal 18 doesn't just suggest a connection, it demands one. The precision of their synchronization is too exact, too perfect to dismiss as random chance. So if these emissions aren't cosmic coincidences, how could they possibly be interacting across such vast distances? One radical possibility is that we're seeing the effects of a hidden structure, something woven through the Kuiper Belt like threads in a tapestry. Picture a network of ancient relay stations, long dormant but still powered, capable of receiving and retransmitting signals instantaneously. It sounds like science fiction, but consider this. If an advanced civilization once inhabited our solar system, or even just passed through, they might have left behind infrastructure designed to operate on timescales far beyond human reckoning. These hypothetical nodes could function like interstellar switchboards, receiving a signal in one location and broadcasting it elsewhere without delay, creating the illusion of synchronicity. Then there's the space-time angle. Einstein's relativity forbids anything from traveling faster than light, but quantum entanglement shows that particles can share states instantaneously across distances. Could some macroscopic version of this phenomenon be at play? Theoretical physicists have speculated about wormhole networks, subspace tunnels that shortcut through the fabric of reality. If such structures exist, even on microscopic scales, they might allow signals to bypass conventional space, linking distant points in ways that appear impossible to outside observers. The Kuiper Belt's icy bodies could be studded with these cosmic short circuits. their true nature hidden until something activates them. But perhaps the most unsettling explanation is that the signals aren't linked by technology or physics at all, but by intent. Imagine a beacon system designed to alert its creators when certain conditions are met. If two sensors positioned light years apart detect the same anomaly, a passing spacecraft, a surge in cosmic rays, they might trigger identical pulses as a form of confirmation. In this scenario, the synchronicity isn't about how the signals are transmitted, but why. They're not just echoes, they're acknowledgements. Yet for all these theories, the simplest answer might still be the most jarring, that we're witnessing a phenomenon so far outside our understanding, it doesn't just bend the rules, it rewrites them. The universe has had billions of years to experiment with forces and materials we've never encountered. Who's to say what's truly impossible in the frozen dark? One thing's certain, Signal 18 isn't just a pair of matching transmissions. It's a clue, one that hints at a Kuiper Belt far more connected and far stranger than we ever imagined. Signal 19 arrived like the last breaths of a dying machine, each burst fainter than the last, each interval longer, as if whatever was transmitting it was running out of energy or perhaps will. Unlike the rhythmic precision of the harmonic cluster or the defiant synchronicity of Signal 18, this transmission felt eerily mortal. Its strength decayed by exactly 1.2% per day, its pulse intervals stretching like a slowing heartbeat, following a curve mathematicians call exponential decay, the same pattern radioactive isotopes use when they fade into stability. But here's what haunts researchers. Nothing in nature follows such a clean, deliberate downward spiral. Stars don't dim by schedule. Comets don't exhaust themselves with metronomic precision. This wasn't astrophysics, it was obsolescence. The signal structure tells the story of something winding down. Early recordings show crisp, square waveforms, the kind produced by engineered systems. Over months, those sharp edges softened, the signal's amplitude wavering like a flickering light bulb. Then came the glitches, skipped pulses, frequency drifts, even what sounded like error codes buried in the static, bursts of noise resembling the diagnostic beeps of failing spacecraft. By the third year of observation, the transmission had degraded into a ghost of itself, barely distinguishable from background radiation. It wasn't just weakening. It was unraveling. Comparisons to human technology are unavoidable. When Voyager 1's thrusters sputter after 45 years in the void, their decay follows this same graceful decline. Mars rovers whisper their final transmissions with similarly lengthening pauses, their solar panels choked by dust. Signal 19 mirrors these death rattles with uncanny fidelity, except it's happening in the Kuiper Belt, where nothing human has ever touched. Unless, of course, we're not the first to send probes into the dark. Theories split between the tragic and the unsettling. Some astronomers suggest a derelict artifact, a probe from some long-dead civilization, its power source finally exhausting itself after millennia of operation. Others propose a natural process mimicking machinery, like a cryovolcanic vent freezing shut in slow motion, its final gasps of radio energy dictated by the physics of closing fissures. But there's a third, darker possibility. What if the signal's decay isn't accidental but programmed? Modern satellites often enter death throes modes before shutdown, broadcasting their status until the last joule of energy is spent. Could this be a cosmic version of that final handshake, a farewell protocol whispered across billions of miles? Then there's the timing. Signal 19's decay curve predicts its final silence will occur in late 2027. A countdown written in radio waves, whether it's the closure of a natural cycle or the expiration of something far more deliberate, one truth is inescapable: we're witnessing an ending. And in the Kuiper Belt's chorus of mysteries, even goodbyes speak volumes. The slow, deliberate decay of Signal 19 raises a chilling question: what happens when the transmission finally falls silent? If this is truly the end, the implications stretch far beyond a simple power failure. Nature doesn't shut down with such methodical precision. Geysers don't taper off by exact percentages. Dying stars don't flicker like drained batteries. Yet here we are, watching a signal that behaves less like a cosmic event and more like a machine entering its final shutdown sequence. Consider the parallels to human technology. When our probes exhaust their fuel or their solar panels fail, their decline follows predictable curves. Thrusters sputter, systems throttle back, and communication becomes sporadic before vanishing entirely. Signal 19 mirrors this process with unsettling accuracy. The way its pulses stretch like a slowing heartbeat, the meticulous 1.2% daily decay, these aren't the hallmarks of natural entropy. They're the fingerprints of engineered systems designed to fail gracefully. But if this is artificial, what could its purpose have been? Ancient beacons don't just broadcast endlessly without reason. Maybe it was a relay, a waypoint in a network we've yet to map, or a sentry programmed to wake at intervals and signal some long-forgotten event like a dormant security system pinging its owners that it's still vigilant. The most unsettling possibility, that we're witnessing the last gasp of something that wasn't meant to be alone. Probes meant for interstellar missions often carry redundant systems designed to outlast their creators. If Signal 19's origin was a civilization that flared and died millennia ago, its final transmission might not just be fading, it might be the last echo of a voice that no longer exists. Then there's the eerie precision of its predicted end date, late 2027. Countdowns like this don't emerge from randomness. Natural processes, radioactive decay, orbital mechanics follow strict timelines, but they don't announce their conclusions years in advance. Unless, of course, something was programmed to. Imagine a failsafe, a final shutdown sequence triggered when reserves dip below a critical threshold, giving observers time to record its last moments. Yet the darkest interpretation isn't that the signal is artificial, it's that its decay might be intentional. Modern satellites often enter death throes modes, broadcasting self-diagnostics before permanent silence. If Signal 19 is following a similar protocol, its meticulous decline could be a message in itself, a way of saying this is not an accident, this is the end. So when the static finally swallows that last whisper, we won't just be losing a signal. We might be witnessing the closing of a chapter written long before humanity looked up at the stars. And the real mystery won't be why it ended, but what it was trying to tell us before it did. Signal 20 defies physics with a single, jaw-dropping trait. It broadcasts at a frequency so high, scientists once swore nothing in the universe could produce it naturally. Clocking in at 340 GHz, this emission sits just below the infrared spectrum, in a range engineers call the terahertz gap, a notorious dead zone where neither conventional electronics nor natural processes are supposed to operate. At that frequency, radio waves behave more like heat than sound, dissipating almost instantly in the vacuum of space. Yet here's the puzzle. This signal doesn't just exist, it thrives, beaming across billions of miles with the clarity of a laser pointer aimed at Earth from the edge of the solar system. The physics behind this impossibility is where theories crumble. To generate terahertz waves naturally, you'd need conditions more extreme than a supernova's aftermath, particles vibrating at near light speed or plasma so hot it rivals the sun's core. The Kuiper Belt, with its frozen wasteland of inert ices and sleepy dwarf planets, should be the last place such energies erupt. Even the most violent cosmic events we know, colliding neutron stars, evaporating black holes, don't cough up sustained emissions in this frequency. Yet Signal 20 pulses on, utterly unconcerned with our textbooks. Then there's the signal's baffling coherence. Most high-frequency cosmic radiation is messy, smeared across the spectrum like static from a broken television. This transmission is surgically precise, its waveform so clean it could have been crafted in a lab. The only earthly comparison, quantum cascade lasers, cutting-edge devices that use nanoscale engineering to punch signals into the terahertz range. These machines are so advanced they're barely out of prototype phase, yet something in the Kuiper Belt seems to have mastered the same physics without circuits, without power grids, without anything we'd recognize as technology. Skeptics scramble for alternatives. Could ultra-rare isotopes in Kuiper Belt ices be decaying in ways we've never observed? Hypothetical dark matter particles interacting with normal matter. Even those stretches strain credibility. The signal's stability suggests a controlled process, not a chaotic one. Its pulses arrive in packets that mirror error-corrected data streams, and its frequency drifts by less than 1 part per billion, a level of precision unmatched by any known astrophysical object. Which leaves us staring into an abyss of possibilities. If nature can't explain signal 20, then what or who is broadcasting from the void? The answer might rewrite not just our understanding of the Kuiper Belt, but the very laws of physics. Because sometimes the universe doesn't bend the rules, it sets them on fire. Signal 20 doesn't just challenge our understanding of physics, it holds a gun to its head. The laws we've relied on for centuries say sustained terahertz emissions shouldn't exist in the frozen depths of the Kuiper Belt. No known natural process generates them. No celestial object maintains that frequency without vaporizing itself, yet there it pulses unwavering, as if the universe itself has decided to break its own rules. So where does that leave us, staring down two equally staggering possibilities? Either our textbooks are missing entire chapters, or something out there has rewritten the script. Let's start with the physics gap. Science has a long history of discoveries that shattered old paradigms: black holes, quantum entanglement, dark energy. Each was once laughed at until the data became undeniable. Could signal 20 be another crack in the foundation? Some theorists suggest that the Kuiper Belt's extreme cold might host exotic states of matter we've never observed, like quantum ice, where molecular vibrations lock into frequencies that amplify radio waves. Others propose undiscovered particle interactions, where dark matter decays into high-energy photons. These aren't just wild guesses. Lab experiments have glimpsed fleeting terahertz emissions from supercooled crystals. But scaling that up to cosmic proportions would require conditions so precise, so improbable, that the odds feel astronomical. Then there's the engineering angle. The signal's precision is its dead giveaway. Natural cosmic phenomena don't calibrate. They don't hold frequencies with the steadiness of an atomic clock. Human technology, though, we do this every day. Quantum cascade lasers, the closest terrestrial match to signal 20, are marvels of nano-engineering layers of semiconductor materials stacked like a high-tech lasagna to squeeze out terahertz waves. If we can build them, why couldn't something else? The Kuiper Belt is old, older than life on Earth, plenty of time for a civilization to rise, fall, and leave behind machinery that outlasts it. But here's where it gets unsettling. If signal 20 is engineered, its purpose is cryptic. Terahertz waves are terrible for long-distance communication. They're absorbed by dust, scattered by plasma. Yet this signal reaches us crystal clear, implying it's either immensely powerful or using physics we don't grasp. Maybe it's not a message at all, but a byproduct of something else: a propulsion system, a weapon, or even a failed experiment flickering into the void. The darkest thought that it's a test, a puzzle meant to gauge whether we're smart enough to recognize the impossible when we hear it. So which is it, broken physics or hidden engineers? The answer might be both. The universe is under no obligation to conform to our expectations, and if something in the Kuiper Belt has found a way to bend the rules, or worse, to write them, the next question isn't just how it works. It's who's listening, because in the grand cosmic game, the first move is always silence. The second, that's up to us. From rhythmic pulses mimicking machinery to eerie echoes of our own transmissions, these 40 signals from the Kuiper Belt don't just defy explanation, they redraw the boundaries of what we thought possible. Each one whispers a different riddle, fractal patterns too precise for chaos, synchronized emissions spanning billions of miles, even terahertz broadcasts that shouldn't exist in the frozen void. They twist the rules of physics like taffy, forcing us to confront an uncomfortable truth. Our understanding of the cosmos might be a flashlight in a cavern, illuminating only fragments of what's really out there. Take the harmonic cluster, singing in ratios found in both quantum physics and human symphonies, or signal 9, bouncing back our own messages with mathematical corrections we never sent. These aren't just anomalies, they're cosmic boundary markers testing the limits of natural law. Some signals behave like dying machines, others like awakened relics, but all share one haunting trait: they feel deliberate. Not necessarily intelligent, but purposeful, as if the universe itself is running experiments we've yet to decode. What's staggering isn't just the strangeness of these emissions, it's their consistency. Prime numbers, Fibonacci sequences, error-corrected grids, they repeat mathematical themes like a language we're only starting to recognize. Nature loves patterns, but not this obsessively. The odds that ice, rock, and plasma alone could produce such layered coherence are vanishingly slim, which leaves two possibilities. Either the Kuiper Belt hides physics we've never witnessed, or something out there is using mathematics as a beacon. Yet for all their mystery, these signals share a single, thrilling invitation to stay curious. Every unexplained pulse, every impossible frequency is a reminder that the universe is far weirder, wilder, and more wonderful than our textbooks dared to suggest. The Kuiper Belt was supposed to be a frozen junkyard, a place where the solar system's leftovers gathered dust. Instead, it's become a hall of mirrors, reflecting back questions we're only beginning to ask. So keep listening, keep questioning, because whether these signals are the whispers of ancient ice or the echoes of something beyond our imagining, one thing's certain: the cosmos has more stories to tell. And the next chapter might be stranger than we've ever dreamed.